Hi, I'm Dr. Incognito. In this video, we're going to discuss the area function. So we'll begin by working on the t-axis here and taking y equals f of t to be some curve. Y equals f of t. And let's say that this endpoint here happens at x equals a. Then the area function is the integral from a to x of f of t dt. So what that means is if you pick a value of x, like that, greater than a, then the value of a of x will be the area of the shaded region. So it will equal the area under f from t equals a to t equals x. Now let's look at a specific example. Suppose I have a function that has a, let's say it's a semicircle, and let's say that's 3, and then let's say it's a line, and let's say that's 5. And then let's say that the line continues, maybe it changes direction a little bit, and that's 6. And let's put some y values on here. Let's say this is 2, so that's the point 6 comma 2, and this one let's say is negative 2, so that's the point, well I don't know what the x coordinate is, but the y coordinate is negative 2. Okay, so let's create, this is the t-axis, actually. So this is my y equals f of t. And I'm going to create the function a of x equals the integral from, say, 0 to x of f of t dt. So we'll start with what is a of 3? A of 3. So a of 3 is the area under the curve y equals f of t from 0 to 3. And that's a semicircle, so the radius of our semicircle here, this would be a diameter of 3, so the radius is half of that. The radius is 3 halves. The area of a circle is pi r squared, so the area of our semicircle is half of that, so it's a half times pi times the radius squared. The radius is 3 halves. We have to square that, so it looks like we're getting 9/4 there. 1/2 pi times 9/4, and this boils down to 9/8 times pi. So a of 3 is 9/8 times pi. How about a of 5? Now this area function is really a net area function. When the function f of t becomes negative, then the integral will count the area times minus 1. So a of 5 is going to be the area of the semicircle minus the area of this triangle. The area of the semicircle we just calculated is 9/8 times pi, and the area of the triangle is half the base times the height. So the base is 2 units, and the height is also 2 units. For the height of a triangle, we always use a positive number. So if that y coordinate is negative 2, then the height here is 2. So we get 9/8 pi minus 2 is a of 5. And we'll look at a couple more. What is a of 6? To find a of 6, we will take advantage of the fact that we know a of 5. And so now we just need to figure out In fact, let me make that explicit. A of 6 is the integral from 0 to 6 of f of t dt by definition of the function. A of 6 would be the integral from 0 to 6 of f of t dt. And that's equal to, by a property of definite integrals, the integral from 0 to 5 of f of t dt plus the integral from 5 to 6 of f of t dt. So the integral from 0 to 5 of f of t dt, again looking at this, integral 0 to 5 of f of t dt is a of 5, which we just calculated. And then plus, this one represents the area of a triangle. In this picture, from 5 to 6, we have this triangle. So a of 5 was 9/8 pi minus 2. And then plus the area of that triangle is half the base times the height. The base is 1 unit from 5 to 6, and the height is 2 units, because that's 0.6 comma 2. And so this is 9/8 pi minus 2 plus 1. So that's minus 1 altogether, 9/8 pi minus 1. And let me embellish this picture just a little bit. Let's draw another semicircle here that goes back to a little bit bigger, -4. And let's ask ourselves, what is f of -4 now? Or a of -4. A of -4 would be the integral from 0 to -4 of f of t dt. And to calculate this in terms of area, we should always have the smaller number on the bottom and the bigger number on the top. And that's not the case here. So another property of definite integrals is we could switch those numbers if we put a minus in front of the integral symbol. So now this integral can be interpreted as an area. The integral from -4 to 0 would be -1 times that area. So we already have a -1 there, and then we have -1 times the area of the semicircle. And so the final answer is just the area of the semicircle. This semicircle has radius of 2. So the area of a semicircle is 1/2 times pi times the radius squared. The radius is 2. And so we get 1/2 times pi times 4. So that's 2 pi. So a of -4 is 2 pi. And one last one. What is a of 0 itself? A of 0 would be the integral from 0 to 0 of f of t dt. And anytime the upper and lower limits of integration are the same, the definite integral comes out to be 0. So a of 0 would equal 0. Okay, so there's a look at